In this video, we're going to talk about some of the properties of gas and the general characteristics of gas. This is part of our Mechanical for Gas course. Okay, so let's start with the chemical composition of gas. It's sort of important to understand how these gases are made up. All gases used to supply heat are called fuel gas. The major part of fuel gas is called hydrocarbons. Hydrocarbons are compounds of hydrogen and carbon. Different numbers of hydrogen and carbon atoms make up different types of gases. Methane makes up the largest portion of natural gas. One carbon atom linked with 4 hydrogen atoms is methane. CH4 is its chemical name. And it looks like this. Okay, we have 1 carbon atom, 4 hydrogen atoms. Ethane is the next type of gas we're going to talk about. Ethane has 2 carbon atoms linked with 6 hydrogen atoms. C2H6 is the chemical name. Now, the reason we do go through this is that some of the state exams and some of the state testing and a lot of the certification exams will actually ask you about the different number of hydrogen and carbon atoms. Okay, and that is important because it does concern the heat content of the gas. So ethane has this appearance. It's 2 carbon atoms and 6 hydrogen atoms. C2H6. Propane is the next one we're going to worry about. Propane has 3 carbon atoms and 8 hydrogen atoms. C3H8 is the chemical name. And that's how propane looks. Okay, 3 carbon atoms, 8 hydrogen atoms. Butane has 4 carbon atoms and 10 hydrogen atoms. C4H10 is the chemical name. And that's how butane appears. Now, the larger number of propane or carbon atoms, the more heat content is in the gas. Okay? The number of carbon and hydrogen atoms in these fuel gases affect the nature of the gas. More atoms in the compound make it heavier than air. Larger number of hydrogen and carbon atoms in the fuel, the more heat is released. Okay, so there's 2 very important things in here. More atoms in the compound make it heavier than air. The larger numbers of hydrogen and carbon atoms in the fuel, the more heat is released. Some additional characteristics of the fuel gas, such as how easy it is to control the flame, depend on the number of carbon and hydrogen atoms. The common fuel gases are not simply one kind of hydrocarbons, but are a mixture of many gases. The fuel gases seen in the HVAC industry may also contain other gases such as carbon dioxide, nitrogen, and free hydrogen. They are not pure. Natural gas is organic in nature from dead and dying plants long times ago. It's usually found in areas where oil is present as well. Some natural gas from garbage and cow manure is now being used. Liquefied petroleum gas, LPG or LP gas, can be propane or butane or a mix of the two. LP gases are transported and stored in tanks. LP gases are usually used in areas where gas pipelines are not available. LPG, liquefied petroleum gas, is stored under pressure. Much of the gas is in a liquid form in the tanks. As fuel is drawn from the tanks, it turns to gas and is burned in the same way as other gases. Natural gas has little or no odor and has no color. Odorants are added to the gas prior to distribution to aid in leak detection and for safety. Most odorants used contain sulfur, which is what people identify as a gassy smell. That's not the smell you smell when there's a natural gas leak or when you open a propane bottle. That is not the smell of the gas itself. That is an additive that has been added for safety purposes. Specific gravity is the weight of a substance compared with the same volume of another substance. Fresh water is used as the reference substance for liquids and solids. So if a specific gravity of a liquid is 2.0, it is twice the weight of the same amount of water. For gases, air is used as the reference substance. Specific gravity of a gas is calculated by weighing 1 cubic foot of the gas and comparing it to 1 cubic foot of the air. Both the air and the gas must be at the same temperature and pressure when this comparison is made. That is extremely important. They have to be at the same temperature and same pressure. And this is done in a laboratory environment. The amount of gas in a given volume will change or vary with pressure. There's a temperature-pressure relationship. The pressure will vary with temperature as gases expand and contract with temperature changes. The specific gravity of air is 1.0, as it is used for the reference material. This is measured with a standard temperature of 69.8 degrees Fahrenheit and a pressure of 29.92 inches of mercury. So again, this is very important. The specific gravity of air is 1.0 at 69.8 degrees Fahrenheit and a pressure of 29.92 inches of mercury. So when we take a look at the specific gravity of natural gas has a range of 0.4 to 0.08, which means it's lighter than air, which is a 1.0. So natural gas, which is primarily methane, is going to be lighter than air. Okay, which is what I just showed you on the chart. Natural gas has a specific gravity ranging from 0.4 to 0.08 to 0.8. That means natural gas is lighter than air. So if there's a gas leak in a basement, the natural gas is going to rise into the rest of the building. That's important from a safety standpoint. Specific gravity of propane is 1.5 compared to air's 1.0. Again, let's look at this from a safety standpoint. So propane has a specific gravity of 1.5. Butane has a specific gravity of 2.0. If these gases are released into the air, they're going to fall and sink rather than rising. They will not mix readily with air, which brings up the safety issue. Propane and butane will drift into low spots and pool, creating an extreme explosion hazard if open flames are present. So let's say you're in someone's basement and you have a water heater or something with a standing pilot or some appliance that you might have had a gas leak with. Okay, if you reach down or turn that appliance on, you may not smell it because it may be around your ankles, but there might be a pool of propane there. So always be cautious and very well ventilate any areas where there might be propane present. Okay, I know a technician that actually reached down to relight a pilot light on a water heater and put his lighter into a pool of propane. You can't see it, you can't smell it. It's down around your ankles, okay? But it's right at the right height for water heater and other small appliances with pilot lights to catch on fire. He wasn't seriously injured. I mean, he was singed, but it was an extremely scary experience for everybody who was around. So be very cautious with propane and butane because they will sink to the lowest spot, and you, since you are not laying on the floor smelling them, you won't be able to smell it. Why do we talk about specific gravity? It has an important effect on the flow of gases through the orifices and into the burners. A gas orifice is a small hole in a fitting. That's called a spud and is used to limit the gas flow to the burners. The gas flow rate through an orifice depends on the orifice size and the pressure upstream of the orifice. The specific gravity also affects how gas flows, as more of the lighter gas will flow through than a heavier gas at the same pressure. The heating value of gas is based on the heat produced when burning a fuel. Okay, and it's expressed as British thermal units, or BTUs. 1 BTU will raise the temperature of 1 pound of fresh water 1 degree Fahrenheit. Burning an ordinary wooden kitchen match, you know, the type that used to come in the boxes, you slide the box open and you have a small tape kitchen match in it, okay, will produce about 1 BTU of heat. But the important part of this to remember, 1 BTU will raise the temperature of 1 pound of fresh water 1 degree Fahrenheit. Now, it's not 1 gallon of fresh water. It's 1 pound of fresh water, 1 degree Fahrenheit. Okay, so 1 pound of water at 70 degrees and 1 BTU of heat added to it means you will have 1 pound of water at 71 degrees. So a few examples here. You need to heat 10 pounds of water 100 degrees. Okay, 10 times 100 requires 1,000 BTUs of heat. The heating value of gas is the amount of heat released when 1 cubic foot of gas is completely burned. Again, heating value, 1 cubic foot of gas completely burned. So natural gas, primarily methane, has a heating value of about 950 to 1150 BTUs per cubic foot. For calculations, go ahead and use 1,000. Propane has a heating value of about 2,500 BTUs per cubic foot, and butane has a heating value of about 3,000 BTUs per cubic foot. So again, the heavier the gas, the more carbon and hydrogen atoms, the more heating value we're going to have. Another measurement of heat energy used, okay, and this is used basically by the fuel industry, is called a therm. A therm is 100,000 BTUs of heat energy. A therm of natural gas is 100 cubic feet of natural gas. And we come up with that by saying 100,000 BTUs divided by the 1,000 BTUs per cubic foot gives us 100. Okay? 40 cubic feet of propane contains a therm of heat energy. So 100,000 divided by 2,500 is 40. That's a therm of energy, or 40 therms of energy. Hourly uses of gas. Input rates are the measurement of the hourly use of gas in an appliance. Input rates will be in cubic feet per hour. Input rates can be converted to and from BTUs per hour. What we do is we take the input, to find the input rate, we take the heating value of gas per cubic foot times the gas flow rate in cubic feet per hour. Now, if we know the input rate and we know the heating value of gas, we can also find the gas flow rate just by using algebra and changing the formula around. So input rate in BTUs per hour divided by the heating value of gas in BTUs per cubic foot is our gas flow rate per hour, CFH. So an example of this, a natural gas water heater needs 35,000 BTUs per hour. We need to find the required gas flow. Okay, easy. We take our 35,000 divided by the 1,000, because our heating value of natural gas is 1,000, and we get 35. Input rates are important for the gas pipe sizing for an appliance and furnaces. The bottom line is the appliance must have enough gas to run efficiently. So that is our discussion about the properties of gas. We've talked about the specific gravity, which is weight. We've talked about several safety aspects regarding natural gas and propane. Propane will pool. Just remember that. That's extremely important. Okay, and we've talked about the fact that the larger the number of hydrogen and carbon atoms, the more heating value that gas is going to have.